Okay, Jessica, I'm going to go ahead and start. I have about 6:24. I'm not sure when you're going to be able to get on. We'll continue this for another hour or more. What I want to do today is move on from what we discussed in class on Monday and move on to other parts of descriptive statistics in terms of calculating certain types of parameters that we can calculate. What I'd like to do is go back to the, well, let's just do that. Let's go here. We'll go back to this week's assignment, which I pulled up. Assignment 2 is going to be formulas. And we'll pull up this document, which we'll bring up. Okay. So what we will do is discuss a few ways of looking at data in using Excel. I will use some data that I have gleaned from another source, looking at the population of cities, and we'll take a look at how to calculate some of these various parameters, such as the coefficient of variation, the mid-range variance, standard deviation, all of these things, mode, etc. And we'll look at how we can do that in Excel. Can you do these things by hand? Yes. Most of the time, though, if you have more than a couple of dozen data points, you're going to want to use some sort of automated system for doing those calculations. Let me just make sure that you're looking at this. Okay, so again, if we look at the assignment for this week, here in the statistics, we've got it's about doctor's visit, and you're going to be doing some calculations of various measures of center. Then we're going to look at standard normal deviation. We'll go to the textbook for part of that. We'll go to we'll go to a couple of other sources as well that I will find along the way. So we'll get started here in a moment. What I want to do first is go to looking at some of these parameters. The things we're going to do are mean, median, and mode. We talked about those. Standard deviation. We want to look at standard deviation. We want to look at range and mid-range. Variance and coefficient of variance, coefficient of variation. And we'll look at z-scores as well. These z-scores are really a way of comparing, again, data sets. It's based on how many standard deviations away from the mean a data set is. We'll look at normal distribution as well. So let's go back to an Excel. I've got some data here for 10 cities in the United States, arranged alphabetically. If we look at them, the populations are all over the map. If we take this data set and copy it, we can manipulate it some. Okay, so we'll copy that over to here. And here we will now sort it. We want to take a look at sorting the data. Let's see. The sort, I never can remember where the sort function is. It's under data, I think. Sort. So we're going to sort from low to high. And we're going to smallest to largest, and okay, so it's now done smallest to largest. Note we've now lost what the cities are, but we don't care. What we're interested in is the data. So we have 10 data sets. Now remember, the median is the number that is exactly in the middle of the data set. Well, exactly in the middle of the data set would be halfway between these two. There's 10 data points, so it'd be halfway between 5 and 6, or the 5.5 position. So we simply add these two up and divide by 2, and we get the mean. So, but we can do this in using the statistical formulas as well. So what I want to do is have a column here, and it's going to be mean, median, mode, standard deviation, range, mid-range, variance, and the coefficient of variance. So we're going to have those things we're going to go through here and use the statistical formulas for solving those. So we'll go here to statistical, and the first one we want is the mean. Well, they don't use mean, they use average. So we're going to use the average. And what we want is we have a range, so we highlight the range. It tells us that. And this number is tells us how many arguments that we want. We want them all, so we ignore it. So, okay, and the mean is 2.454. Let's go down here to the median. And again, we will go in here to statistical functions, and the median is a function we can calculate. And here we can calculate the median and bring it over here. And we get 1.49. Now here is a good look at what we were talking about on Tuesday, which is extreme values will skew the data. If we do this as just a bar chart, we would find that we'd have most of all but a few. The first 6 data points are 1.5 million or less. The next 2 are between are 2.1 and 2.7. Then we jump to almost 4 and over 8. So what we're looking at here is a data set that has some extreme values. So we'll get back to that. Mode is another one. Let's take a look and see. Looking at this, you can look at this and see there are no modes, because mode is something that requires that you that you have a multiple values. Okay, so we have we've outlined our done, um, um, our range. We click OK, and there's no mode. We knew that because there aren't uniform values. But if you were having a large data set, say 500 or 600 data points, you're not going to scan down the list. What you're going to do is do this and find out whether or not there are any repeated values. So now we want to look at standard deviation. Remember, standard deviation is a measure of spread. Standard deviations are based on the mean. And so standard deviation, when you have use an entire data set, and the mean is used instead of the median. So we come down here, and we have two choices of standard deviation. Standard deviation.p and standard deviation.s. Remember from our formulas on Tuesday that standard deviation for a population is calculated slightly differently from standard deviation for a sample. What we have is a sample. We have 10 cities out of tens of thousands in the United States. So we want to do the sample standard deviation. So again, we highlight our range, okay? And all this does is, again, this number is to pull out parts of a population. So we're going to do this entire range, and we're going to calculate the standard deviation. It is 2.18, blah, blah, blah. Now, if you were writing this up, you would look at this and you would say, well, we've got at max 2 decimal points. So this is way too precise. We're going to ignore that for the moment, for the simple reason that I just don't want to get into it. Now, the range here is basically the bottom or the top minus the bottom. So let's look and see if we have a statistical function for range. If we come in here and we find we go straight from quartile to rank. So range is not the one. What Excel has done is basically said, okay, it's easy enough to calculate range, and so we'll let Excel do that for us, and it's going to be equals G12 minus G3. And we enter that, and the range is 7.23. The mid-range, again, we look in and we see that there are, I don't believe there is a mid-range function. In reality, there is. It's called Q2, the quartile. But mid-range is halfway in mid-range is basically, let's see, yeah, it's not there. So mid-range is simply halfway between the two. So it is the range divided by 2. So here we're just going to do, again, the calculation equals G18 over 2, and we'll get that in there. So mid-range here is 3.615. Note, are we here? No, we're not. Are we where? Let's see if you get on. All right, that was just the note you sent to me saying you're having trouble get on. So let's see if you can get on, which ought to occur fairly quickly at this point, I would think. Meanwhile, note that the mid-range is not necessarily the median or the mean, for the simple reason that, again, it is at best an estimation of the middle of a data set that is not a resistant measure. In other words, extremes are affecting this quite a bit. All right, we're waiting still for you to get on. Let's see. All right, I'll keep talking. Variance, if you remember, variance is really the square of the standard deviation, but we can calculate the variance by looking at this formula here, which is to calculate that, and we get the square. If we look at this, this is 2.18 blah, blah squared. And remember, the coefficient of variance or a variation is merely the mean divided by the standard deviation. So it's going to be, there is no function for coefficient of variation. If we look here, it's not there. Okay. So we're going to come here, we're going to divide the mean by, or the standard deviation by the mean. Let's see. I want to be sure I'm doing that too. I always get a little, I'll wait and see if you get on. Give you another minute or so. I'm a little concerned that you can't, that you're not finding it. All right. Yeah, it's the ratio of the standard deviation to the mean, I do believe. Let's go back to our textbook. Where are we? We'll go over here to the textbook and look at measures of variation. We'll go back to to this and once again, get that definition. Okay. I hope things are going okay with you. Yeah, it's the standard deviation divided by the mean. All right. So let's go back to our spreadsheet. And it is going to be equals G17 divided by G14. So the coefficient of variance is 0.89. Now this is a measure of how compact the data happen to be. And so it's a good way to compare data sets. So you'll be doing all of these calculations as a part of your assignment for this week. I'm going to send you a quick email. All right, see if this works. Anyway, so this is the kind of calculation you will be doing in this week's assignment. So let's go back and look at the assignment sheet again. No. Yeah, that's it. So then we're going to look at normal distributions and how we calculate things like z-scores. What is a z-score? Basically, a z-score is a number that you derive by dividing the value of the data point, the difference between your data point and the mean. So your data point minus the mean divided by the standard deviation. This should give us a number between 0 and 1. All right. So let's see, trying to. Well, it should give a number that varies from 0 for the mean to any number to any number. Remember that when we talked about standard distributions, we would have a standard deviation, we would calculate a standard deviation that was there, and we would calculate a number of standard deviations away from the norm. So right on the mean, you're subtracting the mean from the mean, so the standard deviation, so the z-score is 0. Anything that is off the mean will have a z-score. It could have a z-score that was quite large. But once we get past a z-score of about, let me just check right quick here. Once we get past once we get past 2 standard deviations, we are getting down into the 5% range. of a number, getting down to the 5% range of our data. So we're getting to be with outliers, but we can calculate these things and see how far off they are. And remember that 95% of your data falls between plus and minus 2 standard deviations. By definition, anything that has a less than 5% or is more than 2 standard deviations away from the mean is unlikely. And how can we determine the percentages? Well, what we have is the ability to calculate down to to um, 5% down to that 5%. So I'm sorry that we don't have. I'm sorry that we don't have you here in class. I'm going to have to get some things uploaded and sent to you and copied and scanned and sent to you over the weekend. I'm sorry you can't be here tonight. And I need to talk to you about that before this is over. I'm hoping you can get on while I'm online here. Let me just take another quick look at something. Oh. There may be a mistake in what I was looking at. What's going on here? I'm a little confused. No, that's what I just sent to you, I think. Once again, let me check. Yep, that's the one I'm on. So I don't know what's going on here, Jessica. I'm a little concerned if you can't get in. So let's go back here now to, all right, is that you? Oh, stop it. Are you on? No, you're not on. Okay. Well, I find this frustrating. Okay. Why is that? I'm a little confused. This is confusing to me. Um, I'm trying to communicate with you here. This is really strange. I'm going to be unhappy, but that's all right. Let's do that.